Okay, let's keep going with this same section again, hitting on everybody's favorite math F word here for another day. Yesterday might have been a little bit of review with some of the stuff. Today we're going to ratchet it up with as far as exponents go and difficulty. So now we're starting to get into, we said, the extension of Algebra 2 type material. So again, let's look at a couple examples here. Now, only difference between this and something we did yesterday is you have an x to the 6th and an x to the 3rd. Okay? I just want you guys to pretend it's this problem right here. You're really comfortable with quadratics, so make it a quadratic. Okay? What multiplies to 6 and adds to 5? You guys can do the grouping, but that one's pretty straightforward here, like this. Okay, x plus 3 and an x plus 2. Now, we need to somehow get to x to the 6th. So we know our exponent rules are, when you multiply an x to the 3rd, they don't multiply, you add those powers. Now when you do this, you're going to get a 2x cubed. When you do this, you get a 3x cubed added together, gives you the 5 right there. So when you see these with higher exponents, just make it something you guys are able to do. Okay, I'm confident everybody can do this problem right here. Okay, when you're done, just go back and change it. So there's our final answer. X cubed plus 3, x cubed plus 2. In the same way that the quadratics worked in our calculator, these 6 power ones will as well. So if you're not comfortable with these things yet, you can always check if you got them right. Throw that in y1, throw this in y2, and go to the table. Same idea over here. Don't worry about the x to the 6th. Just pretend it's this problem right there. Okay? Now I'm going to do an x method into grouping here. So this will give me negative 70. This will give me negative 3. What gets me to 70? 70 and 1, 10 and 7. There we go. 10 and a 7. I want a negative 3, so I'll make the 10 negative. They multiply up, they add down. The numbers on the side are our grouping pieces. So I'll do 2x squared minus 10x plus 7x minus 35. Now notice, if you switched the order of those two, you would still get something with GCFs. 10 would work with 35, and the first piece you could factor out an x, because 2 and 7 don't have anything in common. So don't worry about the order of the two things on the side. So now GCF the first two, GCF the second two. Make sure these match up, and you have it. 2x plus 7 and an x minus 5. Now, that's only going to get you when you do your first double distributing to 2x squared. You need a 2x to the 6th, so just go back and make it a 3. Okay? Make it a problem that you're comfortable doing, and then change it at the end. The same idea that worked for the first one holds for this. Check it in your calculator or double distribute. All right. Again, completely factor each expression. You see these things, lots of x's going on. 8, 4, 32, they all have something in common. This is an x to the 5th. You should instantly recognize this is a GCF type problem. So 8, 40, and 32. I'm going to pull an 8 out of all of those. X to the 5th, 4th, and 3rd. Pull an x cubed out of there, see what's left. Okay, if you double distribute back through, everything should work. Nothing you can do here, so we're just going to copy that down. Don't forget to fully factor your quadratics. Once you get it to an x squared, you guys are real comfortable with these. Again, I'm not going to do the grouping here. This one's very basic. X plus 4 and an x plus 1. Copy down the x cubed. Again, throw the original in y1, throw your factored form in y2, and they will match up in the table. This next one, 4, 14, and a 10. They all got a 2 in common. You get an x to the 5th, 3rd, and an x. You can only take out the smallest amount. See what's left. Okay, nothing you can do with the 2x, so we're going to copy that down. Now, this in here is kind of basically what we started with in those first two examples. If you don't like the x to the 4th, just pretend it's 2x squared plus 7x plus 5. Okay, do an x method. 2 times 5 is 10, and 7, how are we going to get there? A 5 and a 2. It's nice when everything's positive. So the things on the side are your groupings. So 2x squared plus 2x plus 5x. Remember, that's how we're breaking up the 7. GCF these. And you're going to get a 2x plus 5 and an x plus 1. Now, two things we got to do before we finish this. Don't forget about what you started with here with this original 2x. Make sure you bring that down. Now, we pretended this was a quadratic. It's actually something to the 4th power. So right now, you're only going to get 2x squared. We need to get to 2x to the 4th. So just bump those powers up. X squared times an x squared is an x to the 4th. Okay, I'm going to pause it, throw it in the calculator because I haven't actually shown you guys one in a while. We'll just double check that we did it right. Okay, through the original in y1, through the factored in y2, go to the table, the numbers match up, you did it right. Now, we're going to look at some more advanced factor by grouping examples here, eventually leading into something for you guys who are going to take calculus. You'll kind of get there, but get in some complicated factoring by grouping type stuff. So this first one looks like this. It's kind of similar to what you've seen, but you got an x plus 3 quantity squared here. Okay. These types of problems, like I said, come from calculus when you're doing chain rules and derivatives and whatnot, but you know, a lot of these classes are building mathematical skills, manipulating expressions so you can do those higher level things. Now, I understand not everybody is going to be taking the calculus, but it's still good to have these skills in college algebra. The way you want to handle this is look for things that are in common. A quantity x plus 3. There's only one of them here. So you can only take out one of them. Now I'm going to use a bracket because we're going to simplify a bunch of stuff in here. If you took one x plus 3 out of here, you still have 1 left. Now, start moving your way through. You still got this minus 4x piece left. This is gone because you completely took it out. I'm going to close the bracket up. And then I'm going to simplify everything in here. Okay, so the way you would write this, bring down the x plus 1, simplify everything in your bracket. You may see it in the book with the positive terms first. So we'll do 3 minus 3x here. And you got an x plus 1. Now, this is an example I just kind of made up off the top of my head. I don't think the book will have a lot of these, but notice that it does have a GCF with it. So we should take care of that as well. So let's pull out the 3. You're left with a 1 minus x. And then we should move the 3 to the front. Okay. Again, you can check that in the calculator and make sure it's correct. This next one, you got 4 terms there. Anytime you see one of these, we've actually been doing it for a couple days now, but not with x to the fourth. Okay, do the same things you guys have been doing. Look at the first two. What do they have in common? An x cubed. What's left? What do the next two have in common? A 2x. So you're left with an x minus 3. These better match up. Okay, they do. So we're going to go x cubed plus 2x and x minus 3 here. So we did this problem with the factoring by grouping. You'll notice this one has a GCF. Sometimes you may want to pull that out as well if you want to fully factor this thing completely, I guess. So we could do that, an x squared plus 2 and an x minus 3. Sometimes you may see the book just leaves the answer like that because you did the grouping one. But if you have GCFs, let's try and get those all the way pulled out. Okay, so this expression right here is the same thing as this. Now, why are we doing all this practice with factoring? Because starting tomorrow, we're going to set these things equal to 0, and we're going to start finding solutions, which you guys did in Algebra 2, but like I said, we're going to extend those concepts a lot. Okay, so we're just practicing getting them factored so then we can actually go solve these things. Next, something that looks like this. Same idea is kind of one that you had before. You get two blobs here. This is the first power. This is to the second power. But you've also got two other things that have GCFs as far as the 2 and the 6 go. So take one piece at a time. So I'm going to focus on the 2 and the 6, pull a 2 out. I'm going to go to the bracket and see what's left. Then I'm going to look at, okay, I got one 4x plus 5 here. I got two 4x plus 5s here. I can only take out the smallest amount. So I'm going to pull out a 4x plus 5 here. Okay, go back to the original, see what's left. You pulled the 2 out, it's gone. You pulled this out, it's gone. But it's not a 0. It's got to be a 1. Because when you distribute this back through, you need to get that original thing there. Now move over here. You pulled a 2 out of the 3, 2 out of the 6, so you're left with 3 of them. You pulled one of these out of there, so you're left with this, 1 4x plus 5. Let's simplify this middle bracket. So 1 plus 12x plus 15 when we throw this through, so 12x plus 16. Bring this stuff down. So we'll go 2, 4x plus 5. Now, notice this one has a GCF. So our direction said factor completely. What it has in common is obviously a 4. So let's pull a 4 out. You're left with 3x plus 4 because it wants us to factor it completely. Let's throw these together and get a final product of 8, 4x plus 5, 3x plus 4. So what happens is you get these complicated expressions like this, but really it just simplifies down to that right there. And we can check that in the calculator as well. So I went ahead, threw both of those in. You can see complicated expressions can just turn into simple things like that. You go to your table, not a graph. You see you get the same number. Okay, last example. Factor completely again, but you can see this is way more complicated. This is an expression you'd see in calculus. These things, even though there's a lot going on here, simplify down to very simple things. So if you look at it, okay, start with the 6. What goes with the 6? Well, there's a 3. So let's pull the 3 out. Let's start a bracket because we know we're going to have a bunch of room. Okay, come over here to the x minus 2. Here's the plus sign that separates them. There's 2 of them over here. So we can only pull out the smallest amount. So we'll pull out next one of the x minus 2s. So that's going to be gone. That's going to go to a 1. We said the 3 was gone. That's going to go to a 2. Move further to the right. So 2x plus 3, there's 3 of them. Here's another 2x plus 3. There's only 2 of them. You can only take out the smallest amount. So pull this out here. So this is actually going to be gone. You pulled 2 of them out of here, so you're only left with 1 of them. Now go to your bracket. The 6 turned into a 2, because 3 times 2 gets us to 6. We pulled that out. There's 1 of these left. 2x plus 3. 3's gone. The 2x plus 3 to the first, squared is gone. We pulled all of those out. And then there's 1 of these x minus 2's left over. We cross the plus sign, so make sure you copy that down there. Close up the bracket. Take care of this thing right here. So distribute this. You can just drop your parentheses here, collect your like terms, and you get a 5x plus 4. Copy all of this stuff down, and you'll have it. So 3 and x minus 2, a 2x plus 3 quantity squared. We'll scoot this 5x plus 4 over. And this big complicated expression just simplified down to this. Okay, so we'll see you guys tomorrow. We'll practice that stuff in class.